Yeah, I mean, it'll be emailed, it'll be on the website, and that. I mean, right now I'm going to be going back and forth between it. So on page 36, the 31 to 34, let's go back to 36. Was this section. Actually 37. (31 to 34). Okay. Given 2 points, find the distance between them and the midpoint. Okay. How do you find? Let's take 1, 1 and 9, 7. Okay. How do you find the distance between those 2 points? Right? If you remember, we've got a formula for that. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So just in a very, programmatic kind of way, I mean, you could just plug in the formula if you remember the formula and get a distance. And that would be 9 minus 1 plus 7 minus 1, which is 8 squared plus 6 squared, which is 64 plus 36, which is the square root of 100, which is 10. Remember, you could also plot the 2 points, right? Go like this. 1, 1, and 9, 7. Let me erase all that. Oh, that was wrong. Edit, undo. Better to do this. Okay, 1, 1 is here. 9, 7 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Right? We're trying to find the distance between the two. Do you remember how we can do that? Make a triangle, right, that goes from like that. We're trying to find that distance. Well, we could use Pythagorean theorem, right? That's a right triangle. Right, the difference from 1 to 9 makes that side 8. The difference from 1 to 7 makes that side 6. So this side is the square root of 8 squared plus 6 squared. Right? In either way, you're going to get the same arithmetic when it comes right down to it. But it might help just graph it and then see it as a right triangle. Okay, the other part of that was, how do you find the distance between those two? Or sorry, the midpoint. Right, and what do we mean by the midpoint? We mean if you connect these two with a segment, then somewhere in there is exactly halfway between those 2 points. How do we find that point exactly? Do you remember the math behind that one? It's the average of the x's and the average of the y's, right? You're going to add up 1 plus 9, divide by 2, and that should be 5. Add up 1 plus 7, that's 8, divide by 2, that's 4. So let's go back here. Midpoint. Right, x1 plus x2 over 2. y1 plus y2 over 2. In this problem, 1 plus 9 over 2. 1 plus 7 over 2, which is 5, 4. I mean, the thing to remember about the midpoint is don't be apples and oranges wrong on the midpoint. Don't give a value like one number It's a point. It's going to have two coordinates, right? It's not just a number you're calculating here. And if you understand it as a point, and you went through your calculation, and then you went to your graph, and it didn't look like it was in the middle, you plot your point, you might want to just check that way to see, does it look reasonable that that point could be the midpoint of that line? I mean, a common mistake that you're going to make here is that in the calculator, you don't use parentheses around the numerator. You try to just do it in one step, 1 plus 9 divided by 2, without parentheses. The calculator will do 1 plus 9 over 2, which is 4.5, so you're going to get 5.5. That's not correct, right? So that's why it would help. Once you've calculated it, just go to the graph and see, does it look reasonable? If it's not reasonable, you might want to check your math. Okay. That's what you're trying to get out of these two problems. Do a practice calculation of distance and midpoint. The 49 to 60 on the same section. Not on that page. Find the x and y intercepts of a graph, like we just did in the quiz, right? So let's take one just for fun. I don't want to do one that's too bad, but how about we'll just do 49. Y equals 16 minus 4x squared. Okay, the x-intercept, right, substitute y equals 0, solve for x. So in this case, 0 equals 16 minus 4x squared. Solve. Add 4x squared to the other side. Divide by 4. Take the square root of both sides. What does x equal? Plus or minus 2, right? Don't forget that, plus or minus. So the intercepts are 2, 0, negative 2, 0. Okay, for the y-intercept, right, substitute. X equals 0. Solve for y. Okay, well, if x is 0, then what happens to that whole last term? It's gone, right? So y equals 16. Right, so the point is 0, 16. Okay, x and y intercepts. There'll be one just like that. Okay, then we jump to the next page, 49, 15 to 24. 49, we're on 38. That's too many pages. Let me go up to that. Okay, what did I say is the numbers? 15, so I need to go one more page. 15 to 24, what are we trying to do? Oh, right there. Uh, 15 to 24, find the slope and y-intercept, if possible, of the equation of the line, sketch the line. Okay, and specifically, you're going to be given a line which is not already in slope-intercept form, right? Because some of these, like this one, this one, this one, this one, they're already in slope-intercept form. You should be able to say, like this one, the slope is 5, the y-intercept is 3, right? The slope is negative 1/2, the y-intercept is 4. But how do you deal with it if, like on 24, 2x plus 3y equals 9? Now how do you say the y-intercept? solve for y, that'll put it into slope-intercept form. So that's the strategy, usually, with a problem like that, right? 2x plus 3y equals 9, right? Find slope and y-intercept, right? Solve for y. Right, so what's that? Subtract the 2x. Divide by 3. Okay, and then let's say you get it to that point. You still got to tell me which is the slope and which is the y-intercept. Don't just leave it like that. Answer the question, right? Because then I may be unclear whether you really know which part of this is which, right? So we would say, and you can use the m and b if you want. Go ahead, Julian. Right. M is negative 2/3 and b is 3. You just take that last step and say what it is. Now, if you had to sketch the line, which honestly I don't think that's part of the question on the test, it just says find the slope and y-intercept. But let's say we were going to sketch the graph of the line. M is negative 2/3, b is 3. Okay, b is 3. That means you go, m is negative 2/3. Want to get that? Mitch? B is 3, so go up here. And then how do we use the slope at negative 2/3 to find another point on the line? Right? How do you use this negative 2/3 to go from here to another point? Say again? I know you're all distracted. This is fine. Negative 2/3. Down 2, right 3. So go down 2, right 3. Make another point. Okay. Draw a line. Okay, 25 to 34. Same page, 25 to 34. Okay. Find, basically you're going to be asked to find the slope of a line passing through 2 points. Let's take two. We've already done this, but let's take two. Negative 3, negative 2, and 1, 6. So what's the formula again? M equals y2 minus y1 over x2 minus x1. So that's 6 minus negative 2 over 1 minus negative 3, which is 8 over 4, which is 2. And definitely simplify it if it can be simplified. You might also, plot those 2 points on a graph and just make your triangle, right? It's the length of the vertical side of the triangle divided by the length of the horizontal side of the triangle. Okay, next, 55 to 64. That has got to be the next page. 55 to 64. Okay, and we've done this one already once today. How do you find the equation of a line that goes through 2 points? Ariel? You're going to use point slopes, right? And first you're going to have to calculate slope. Okay, let's do the first one. 5, negative 1, negative 5, 5. 5, negative 1. Right, slope-intercept form of line. Okay, so first thing, calculate a slope. 5 minus -1 over -5 minus 5, which is 6 over -10, which is -3 over 5. All right, and then we use point slope, right? Y minus y1 equals m times x minus x1. Okay, y minus, and it doesn't matter, I'm going to use this one, I guess. Y minus -1 is y plus 1. I'll simplify that right away. And now I've got -3/5 x minus 5. Right, but then you need to solve for y. Right, so solve for y, that means y plus 1 equals -3/5 x. And what's -3/5 times -5? Positive 3. The 5's cancel, right? 5 cancels with 5, and negative times negative makes positive. Okay, then what? Subtract 1. Y equals -3/5 x plus 2. Good. So our next, okay, 15, 20, 55 to 64, 73 to 80. 73 to 80, I think is at the bottom here. 73 to 80. Okay, write the equations of lines. If you know a point and you're told that your line is parallel or perpendicular to another line, right? So what do we know about the slopes of parallel lines? They're the same. What do we know about the slopes of perpendicular lines? Opposite sign and flip the fraction, right? Negative, opposite reciprocals, right? That's what you'd say. So you want to take, let's take, for example, 3x plus 4, oh, that's got too many fractions in there. How about we take the 4x minus 2y equals 3, and the point is 2, 1. Okay, so for parallel, you know, well, I shouldn't even do that part yet, right? Because what do I have to do so that I know what the slope is of the line that we are comparing to? I got to solve for y, right? So I need to say that's -2y equals -4x plus 3. Divide by -2. So y equals 2x minus 3/2. Right, so what is the slope of this line? 2, right? This line has a slope of 2, right? So a parallel line would have a slope of m equals 2. A perpendicular line would have a slope of -1/2. Opposite sign, flip the fraction. Okay, once you know that, then you're using this point and the appropriate slope in the same way that we already have in point slope, right? If it's parallel, then I'll have y minus 1 equals 2x minus 2. If it's perpendicular, I'll have y minus 1 equals -1/2 x minus 2. Solve for y, which I'll leave that out just to save a little time. Right? So remember, when you get that parallel perpendicular, they're trying to tell you the slope, just not in a direct way. Okay, next. 62. 62, we're on 50, that's way too far. So let's go to this. And we want 11 to 20. (11 to 20) say, okay, we've already done this one. We don't need to make a slide for this, right? How can you tell whether these represent y as a function of x? If the y is squared, actually, not just squared, right? Raised to any even power, right? If y is raised to any even power, then the last step, when you take the square root or the fourth root or the sixth root, you have to have plus or minus, and now it's not a function anymore. Okay, so you're looking for that. Let's see, definitely this one was not. This one was not. Let me see if they've got a. Yes. All right. So just look for those two situations, or that one situation. Y is squared or raised to an even power. Right. The next 21 to 30, and I've got it in the parentheses there in the study guide. It says just the part C. Okay. See, there's going to be more parts to this, but we don't care about all of it. So 21 to 30. Right. This is where we evaluate functions. So if you notice, the part C is the part that's like you're substituting with an expression. You're not just putting a number in the function. You're going to have something like x minus 1 or 2r or x plus 2 or x minus 8. You know, it's going to be something more than just plug in a number. So let's take one for, how about t squared minus 2t and h of x plus 2. Right? How do you find, if that's the function, how do you find h of x plus 2? Yeah, in the function, right, you're going to replace every place you see a t, you're going to put an x plus 2. So this here is going to go here, and it's going to go here in the place of t. Right? H of x plus 2 is x plus 2 squared minus 2 times x plus 2. Right? Everywhere you saw a t up here, put an x plus 2. And then simplify. Right? X plus 2 squared is not x squared plus 4. It's x plus 2 times x plus 2, which is x squared plus 4x plus 4. And negative 2 times x plus 2 is minus 2x minus 4, which is x squared plus 2x. And the 4 minus 4 cancel. Okay, let's see. Now we're up to 31 to 32. A lot of these were homework problems. We've already done them. Right? You should have them in your notes. You should already have like worked out answers. Okay, I'm not going to do the whole thing, but what are these again? Piecewise defined, right? So you should know how to evaluate a piecewise defined function, right? How would I find f of 2 in this problem? Use the bottom one because, yeah, because this is for the x values greater than or equal to 0. So put in the 2 there, or put in the 2 there. 2 times 2 plus 2 is 6, right? If you want to do f of negative 1, then you would choose the top one because negative 1 is less than 0, right? If you had to do 0, the or equal to is on the bottom one, so you use the 1. Next. (37 to 40), which is on the next page. (37 to 40). Okay. The directions here, again, you're going to use this as your study guide. It says, find all the real values of x such that f of x equals 0. What are they asking for here? The values of x that make the function equal 0. The zeros. I mean, that's what we call the zeros, the x-intercepts, the solutions, all those words, right? So that's all that's being asked for here. I mean, it's like when we found the x-intercept, we substituted y equals 0, we solved for x. That's what you're doing here. Substitute the f of x, which is like y equals 0, solve for x. Okay, so most of these are, you know, linear or fairly easy to solve if you got to that point. Remember, like in a fraction, like this one right here, if I was trying to find the zeros, if a fraction equals 0, it's because the numerator equals 0. The denominator has nothing to do with it. So you just set the numerator equal to 0, solve for x. So find the zeros of a function. On the test, it says find the zeros of a function. Find the zeros. There's two questions, right? There's one that says find the zeros algebraically, meaning solve it like you solve an algebra equation. Another one says graphically, which we'll get to in a minute. And 49 to 60. (49 to 60). Find the domain. Again, we made a lot of mistakes with this, but again, these were homework problems. Remember, what are the two situations that we are looking for that will restrict our domain from all real numbers? Divide by 0, square root of a negative, right? Just those two. That's all you got to look for. Like these first two, if you're not dividing, you're not taking square roots, all real numbers, right? Nothing to say. This one, if you divide by 0, what would be the value of t that makes you divide by 0? 0. So you say domain is t does not equal 0. This one, what is the value of y that makes you divide by 0? -5. Y does not equal -5. Okay. If you're given a square root, how do you take what's inside, right? Y minus 10. Let's do that one. Right? You take that y minus 10 and you set it greater than or equal to 0, because that's what has to be true, right? If it's not greater than or equal to 0, it's negative, and you can't take the square root of a negative. So solve that for y. Y is greater than or equal to 10. That's the domain. Right? You can plug in any value of y that makes that true. Okay. Okay, that's that. Page 74. 74, too far. Probably it's going to. Get off of that. And what was the problem again? That was 7 to 10. Some of these we just did. 7 to 10. Right? Find the domain in the range, and then find the indicated function values. I believe on the test, just so you know, the only part of that you're really being asked for the function values, not the domain and range by looking at the graph. So, for example, on this first one, how do you find f of -2? You're looking at the graph. You go on the x-axis, you find -2, and then you read off the y value, 0. right? How about in this one? What is f of negative 1? Go over to negative 1, up to the graph, the y value is 4. That's what you're being asked to do in those problems. Just evaluate the function. Okay. Next, 15 to 24. Well, here's another. It says find, it's a little bit of a mistake, I'd say, but we already talked about finding the zeros of a function algebraically. How do you find the zeros of a function with a calculator? Graphically. Right? You're going to put it in your calculator on the y equals line, right? Clear. Clear, clear, boom, boom. So let's say I was going to do the first one, 2x squared minus 7x. 2x squared minus 7x minus 30. Right? Graph. So where do you look on that for the zeros? On the x-axis, right? So definitely you think 1, 2, 3, 4, 5, 6, 7 looks like it's a 0. How can you confirm that? Well, you could do that, or since it looks like it's an integer value, actually that was a 6, because you can see right there in the table of values, x equals 6, y equals 0. Okay, there's one. And the other one looks like it is in between -3 and -2, and it's not a whole number. I think on the test they are integer values, that you won't have to do this. But if you remember, if you have to find the 0 that's not right in your table of values, that's second trace and 2 for 0. Right? And then for the left bound, I'm going to enter an x value over here. Let's say -5. For the y value, or for the right bound, I'll put an x value to the right, let's say. And then I'll guess. And it looks like it's -2.5. Okay, we're up to 31 to 38. Okay, these were the ones where you had to say where it's increasing and decreasing. Do you remember what was the key part of saying the intervals of increasing and decreasing? Say, you just said it. Use x values, right? Like if I want to say that this graph is decreasing from this point to this point, I say that it's decreasing from 0 to 2, right? From 0 to 2, not the 2 to -2. Don't use the y values, right? It's increasing from -infinity to 0. From -infinity to 0, it's right there. It's increasing from -infinity to 0. It's decreasing from 0 to 2. It's increasing from 2 to infinity. And you could say that in any way you want. You could use their interval notation. You could use less than symbols, greater than symbols, whatever you want. And the 47 to 54, which is 47 to 54. Okay, and these problems, right, on the test, you're given the graph. But and here, they don't have anything for us where it says find the maximum and minimum looking at a graph. They just give you some equations. You're supposed to put them in the calculator, but you're going to be given the graph. You don't have to do that part. So basically, it'd be like saying on something like this, estimate the maximum and minimum points. And, you know, I would look at that and say, well, that's the maximum point, right? It's not the highest point on the graph, right? There's a higher points here, but it's a relative maximum because it's the highest point in its area, right? You know, it goes down to the right, it goes down to the left. It's a turning point in the graph. So you would estimate the maximum is 0, 2. And the minimum looks like 2, -2. So looking at a graph, just try to be able to estimate those points. And remember, if there's more than one, there can be more than one minimum and maximum, right? Because they're not absolute, they're relative. The graph can go, many squiggles in it. Every turning point is a maximum or a minimum. And last, next 83, 35 to 40. So I think I need to go here. 83, wasn't that this? That was the, this one. Oh, yeah, I know what it is. Nope. So 83, 35 to 40, sketch a piecewise function. Right? Remember, what's the important part of the piecewise function? It's a function, right? Don't draw the graph, two graphs in the same part of the domain, because then it wouldn't be a function. And by all means, know how to do it in your calculator. It's okay if you do it that way. Just make sure if you're transferring it over, you're giving enough detail to see what's going on. I mean, the shape is one thing. Which piece has the endpoint included and which one doesn't, things like that. So that is the whole study guide, right? And what's going to be expected on the test. You don't have to do every problem, but you should do some of each just to say, and check your answers. I get a question, one not from this class, but from another class, a parent saying, well, how is my kid supposed to study? Tell me how to study. Do some problems, check your answers, hold yourself accountable for, did you really understand it or not? If you can't figure it out yourself, then you need to ask a question, right? But try. It's extra credit before the test. If you didn't do a homework in the chapter, I fill in a missing homework. If you did all the homework, I add it to the test score. And that's how it works. If you don't do a study guide and get all the credit for it, then I'm not offering you a retest, right? You're just going to take whatever grade you get. So do it. Do an honest effort of it. I usually look through, I'm pretty generous the way I look through, but I see like whole pages you never actually got to. Or it's just like copying the problem, but you actually didn't do the work. I mean, can I really say that you prepared for that? I mean, if you didn't prepare, is it a surprise you don't pass? So if you work hard and you didn't pass, I want to offer you a second chance. That's my point. Okay, let me stop this.